Good morning, students. So here today we will discuss about the crystal field splitting in octahedral and tetrahedral complexes. So we know that when octahedral complexes are different from tetrahedral complexes. So here in octahedral complexes, 6 ligands are approached. In octahedral complexes, 6 ligands are approached. In case of tetrahedral, 4 ligands only approach. So you know that when splitting of d orbitals is called splitting of d orbitals. So when the ligand is approached to the d subshell, they are split into 2 sets. One is T2G set, other one is EG set. So here T2G set and EG set. So EG set means dx square minus y square. T2G set means dxy dyz dz. Like that they are splitting. But in case of tetrahedral, T2G set has more energy. In case of octahedral, AG set has more energy. So and stabilization energy is considered as 4 by 9 into delta naught. So delta naught is the standard stabilization energy. So for this, now we are discussing about the strong field ligand. So in case of strong field ligand, the distribution is like this. For D1 electron, D2 electron, D3 electron, D4 electron, D5 electron, D6 electron, D7. So in case of strong field ligand, pairing of electrons takes place. So pairing of electrons takes place means now we write the distribution. So here D1 equal to 1, that is 0 point delta naught. Unpaired electrons I have mentioned 1, 2, 3, 2, 2, 1, 1, 0. So and stabilization energy also given here. So how can we calculate stabilization energy? I will take one problem. I will explain that problem. So here, arrange the problem is arrange the following in the increasing order of stabilization of energy, stabilization of energy following in presence of strong field ligand. So here, so D2, D3, D4, D5, D9, D10. So I will calculate how just for we are calculating. For D2, how can we calculate how many unpaired electrons are there? 2 and 2 unpaired electrons are there. Therefore, for D2 electrons, we will write 2 into 0.4 minus 0 into 0.6. So therefore, this value becomes 0.8 delta naught. How? Here, once you check D2 orbital, so here distribution is takes place in, for this 0.4 for T2G and 0.6 for EG. Therefore, that value is, so how many unpaired electrons are there in T2G? 2 unpaired electrons are there. In EG, how many electrons? 0 electrons. This is the calculation. How we are calculated, I have given here data. So, increasing order of stabilization of different orbitals. Here D2 is calculated and we calculate D2, D3, D4, D5 to D9. So up to D10 I will calculate here. First I will write. So here, first I will calculate for D2. So D2 I will calculate D2 equal to 2 into 0.4 minus Point into 0.6. That value is how much? 0.8 delta naught. That value. For D3, how can we calculate? How can we calculate D3? Here, how many unpaired electrons are there? 3. Therefore, here D3, I will write 3 into 0.4 minus 0 into 0.6. So here, the value is 1.2 because here the unpaired electrons are 3. Therefore, this value is 1.2. This value is 1.2 delta naught. Simultaneously, I will calculate D4. So for D4 also, how many electrons are present here? D4, 4 electrons are there. So 4 into 0.4, there how many electrons are there? 0 electrons are there. So for D4, 4 into 0.4 minus 0 into 0.6. The value is 1.6 delta naught. 1.6 delta naught. So D2, D3, D4 is calculated. D5. So D5, how can we calculate? So how many electrons are there? 1, 2, 3, 4, 5 electrons are there. Therefore, D5, 5 into 0.4 minus 0 into 0.6. The value is 2 delta naught. This value is 2 delta naught it will come. So here 6 into 2.4, 6 value D5 and D9. So D9 value, so D5 value like this we can calculate. After that, after that we can calculate. Some more examples are given here. So we are taking D10. D10 how many electrons will come? 6 into 0. Like this. This is the process to calculate the stabilization energy. For example, if you take D9, 6, 3. 6 electrons and 3. D9 electronic configuration is, I will write here 6 electrons and here 3 electrons. This is the configuration. Therefore, how much we get? 1.0. How much we get? This much value we can get it. So this is the value. So D4 and D9 here 0.6 here. So 0.6 for strong field ligon. This is 0.6, 1.2, and this is 0.0, and after that this is 1.6 and 2.0 here. So this is 1.8. The value we calculated here. So this is the stabilization energy. How can we calculate? So first you write the distribution of electron. Here 6 electrons are there. Here 3 electrons are there. So 6 into 0.4 and 3 into 0.6. For D9 electrons I will write like this. For D9 electrons I will write 6 into 0.4 minus here how many electrons? 3 into 0.6. The value is approximately 0.6 like this. So first to write the electronic configuration. In case of strong field ligon, what happened? So just you have to calculate these values. By calculation we get these values. So how? In case of strong field ligon, pairing of electrons takes place. So like this we can arrange. Sometimes they will ask D2, D3, D4, D5, D6, D7. I am given D2, D3, D4, D9 electrons. So this is the way to find the stabilization energy of electrons. I am already given. So for D1 how to calculate, for D5 how to calculate, for D9 how to calculate. So these are the values here 0. So this is the stabilization energy of the, so 0.4, 0.8, just you have to calculate. By substituting all these values you can get the values. So this is about crystal field stabilization energy. Here we are taking strong field ligand. For this we are taking weak field ligand. How can we calculate how much value is there for weak field ligand? Weak field ligand is different from strong field ligand. So here I will write for weak field ligand. So for weak field ligand also we can write configuration, distribution in weak field, stabilization energy and the number of unpaired electrons. I will write first one configuration. After that distribution in weak field, distribution in weak field. After that stabilization energy, and number of unpaired electrons. Here this is for weak field ligand. So weak field, in case of weak field, how much? Here also T2G and Eg. So Eg for 2 and here 3. So how can we write D1, D2, D3, D4, D5, D6, D7, D8, D9, D10. So how can we write this electronic configuration? So for D6 we can write 0. How much value we get? I will write here. So here this is 1. This is 2 means here 1 electron, here 1 electron. 3 means here 1 electron. 4 means 1 and 1 here. So 5 means 1. Here also 1 electron. So 6 means here, in case of 6 here, 2 electrons are here 1. This is the 6. So like this we can calculate the values also. After we calculate it, we get the values here. I will write the values for D1, D2, D3, D4. So first one for D1 is 0.4. D2 0.8. For D3 1.2, for D4 0.6, for D5 0.05. So 0.05, like this we can calculate so the values. So you know the same formula we can substitute it here. So number of unpaired electrons are 1, 2, 3, 4, 5, 6, 5, 4, 3, 2, 1, 0. So here 1, 2, 3, 4, 5, 4, 4, 5, 4, 1, 2, 3, 4, 5. In 5 orbital, 5 electrons only there. So 4, 3, 2, 1, 0. This is about for weak field ligand. So for weak field ligand also we have calculated the energy. After that we will do the one problem for weak field ligand and strong field ligand. So far I will take one problem. Give the stabilization energy of. So I will write the one problem here. So here give the stabilization energy of D7 electron in presence of strong and weak field ions. In presence of strong and weak field ligands. This is the question. So, strong field ligand and weak field ligand. So, weak field ligand stabilization energy is different. Strong field ligand stabilization energy is different here. 6 into 0.4 minus 1 into 0.6. Here 5 into 0.4 minus 2 into 0.6. This value is 1.8 delta naught. Here this value is 0.8 delta naught. That is the distribution of electron state space in different conditions. Here 6 and 1 element, 5 and 2 element in case of weak field ligand. So it is weak field ligand and strong field ligand stabilization energy. So that is the different here. So weak field stabilization energy is different and strong field stabilization energy is also different. This is about crystal field theory and stabilization energy calculations. So calculation of stabilization, how can we calculate stabilization energy? Means like this we can calculate. With strong field is different, weak field is different. How can we calculate? 0.6 into 0.4 number of electrons we are taken in easy orbital and T2G orbitals, and value is constant 0.4 and 0.6. This is about crystal field theory.